Is it full screen now?
Yes.
Okay, fine. Okay, so let us start with the this webinar. Now, let me clear that this webinar is basically focused on to interact with the students only. So I kept my contents like that so that the students will get benefited. And I will start with the basics only, and then we'll go ahead with some case studies and all. Okay, so the contents are like this. We'll take some introductory part to understand the basics of structural engineering first, structural engineering concepts, which is required for software modeling and all. Of course, I am not going into the depth of your structural analysis or design subjects, but the whatever required for understanding the behavior of the structure, once you model your structure into the software, so to understand the behavior, whatever the basic things are required, that we will discuss first. That is the first part of the presentation. The second part will go with RC design of RC 3D frame. Okay, why I'm calling it as a frame? Because the entire building generally is not symmetrical most of the cases. So I am just taking an example of one 3D frame, and then we'll start from the scratch and we'll model the entire building using STAAD.Pro, and then we'll apply the seismic load on the building. Now here there are two things. One is seismic and another is wind load generation. These are very important as far as your STAAD is concerned. But now I'm going with the seismic load generation for RC building and then wind load generation for industrial building. The reason behind this is very simple. Because most of the cases the RC building is governed with the seismic loading. Wind load may not govern in case of RC building. The reason is your weight of the structure. Weight of the structure is very high in case of RC compared to your steel structure, which is your industrial building. So that's why we'll take an example of 3D RC frame analysis for seismic analysis, seismic load generation. And then we will take the example of industrial building for wind load generation. So wind load generation is again a very important parameter once you go for industrial building, because most of the cases these industrial buildings the wind load is governed, seismic load may not govern. The reason is again the same one. The steel structure will be having less weight and it is flexible compared to the RC building. So generally wind load will govern there. And again the height of the industrial building is again limited. So most of the cases you will be having some shades kind of thing, where you have pitch roof shades, and then length may be anything between 10 meter to maybe 100 meters. Okay, so but the height is always limited. Maybe you can have a height up to 20 meters if it is a double story with gantry and all. So industrial building is mostly governed by the wind load. So we'll take an example of industrial building for wind load generation. And the third one, which is very new topic maybe for you, because academic, most of the syllabus all over the India may not cover these types of topics like pipe rack structure design and all. So these are the structures which is used for the oil and gas industries, maybe in offshore industry, or maybe you have got say service building or substation building. There are number of pipes which are running, chilled water pipes and all. So to support that structure, these pipes racks are constructed. Now we are not going into the depth of these types of structure again, but I wanted to give you an overview of analysis and design of these types of structures. So what are the different loads other than your normal loads of wind, seismic and dead live? These loads to be considered for design of such types of structure, that we will discuss only. So these are the broad contents of today's webinar. Okay, so I will start with the first content, that is we'll just discuss the basics of the structural concepts. Okay, so what is structure basically? So structure is an assembly of the different elements. Now for civil engineering, it is an assembly of beam, column, slab and footing. When you talk about the building, it is an assembly of beam, column, slab and footing. Okay, so all these are connected with certain points, and that is called as a node. So nodes are the connecting point of the structure where these different elements are connected. Then we will discuss about the types of the structure here. So what are the different basic classification of the structure? So like your frame, then shear wall frame, then you may be having cables. So like that, there is a basic classification that we'll see first. Then loads, what are different loads which are coming on the structure and how they are classified based on the direction of the load and then the response of the load. Then we'll talk about supports and their reactions. You must have learned this in many of your subjects like structural analysis 1, 2, maybe in strength of material, mechanics of material, whatever. So these are very, very important parameters as far as your modeling is concerned. So everything, whatever you model, ultimately it goes to support. Okay, so whatever the loads you are applied on the structure, that should be in the form of reaction. So the load part should be correct. So for that, you should understand the various types of the supports and how reactions are generated based on these supports. Then we'll discuss about the computational model. So what are the different computational models that can be prepared for analysis purpose and how the simulation can be done, and then of course various analysis techniques. So these contents will be covering briefly, and then we'll go to the STAAD Connect edition. Okay. So the structures are classified like this. So basically there are 4 or 5 types of the structure. First category is always a truss type structure. In truss type structure, we assume that this loads which is there in the member is only a two force member. That means only axial compression or tension will be developed in the truss, and no bending action will be there. So that is called as a truss type. Of course, you should have a triangulated geometry everywhere to behave like a truss type this structure. But there are again constraints practically once you put the two bolts, because for analysis purpose we will be assuming that each joint is a pin joint or hinge joint, but once you put two bolts or two rivets, it may not be a purely hinge type behavior, right, or pin type behavior. So there is always a fixity, so partial fixity will be always be there. But for simplification, we will assume that all forces in this particular type of the structure are either tension or compression. So it is a two force member, that is the first thing, and there is no bending at all, right? So that is a truss type structure. The second type is cable or arches. The difference between the truss and the cable is, this cable is a flexible member, so it will take only tension. There is no compression. So the truss type member will take tension as well as compression, whereas the cable will only take the tension, right? So it is mostly used for the bridges, or sometimes it may be used for the pre-stressed precast structures also, right? So these are cables or arches. Yes, arches is another part of the structure where the external action is resisted with the help of the arch action. Now, arch action is a very Asian type of the structure which is used, where the tension and compression is balanced with the help of these arches. Now, it is like a pre-stress which is induced in your particular structure, where the external load is balanced with the help of pre-stressing action. Okay, so third type is of course a conventional frame type structure where you have what number of beams and columns, and sometimes it may be with the shear wall also. There we'll call it as a dual type structural system where wall and frame will interact at each of the level, and the lateral forces is resisted. So this is very conventional type of the structure which is your frame. And then the last category of the structure is surface structure, where you have got domes, and whatever the architectural part is there in the surface. These are a plate type or surface type structures. So these are the basic classification of the structure. Now, based on this classification only, the response of the structure you have to predict, right? Okay. Now loads, you know this already, but I am again repeating all these parameters for you to understand. The loads are basically classified as a gravity load and a lateral load. This is the loads which are coming on the buildings, but this is the classification based on the direction. So if you ask me for the type of the load, that may be concentrated load, maybe distributed load or varying load. Some loads are temporary loads, some loads are permanent load. Like that, the classification is possible, but this is more relevant to you, where you have got basic two types of the load. One is gravity and another is lateral type of the load, where you have got wind, earthquake. These are the major loads which is coming on the structure. Apart from that, there may be water pressure, blast and impact. That is also a lateral load. Sometimes there may be water pressure, which will produce an hydrodynamic action. So that will be also a part of a lateral load, which is your apart from gravity load, which is your horizontal load. So this load is more dangerous than gravity load. Okay, then the gravity load, of course, you have got dead load and lie load, and then lie load, maybe floor lie load or roof lie load. Snow load is also comes under the category of lie load, right? So this is related to the building, and this is very basic classification of the load for the buildings. Now, talking about the supports, there are three types of the support you have already seen. Again, this picture will show you the different types of the supports, where there are basic classification like hinge support, roller support, and hinge support, roller support, and fixed support. So the thing is, whenever you say roller, the reaction is always perpendicular to the roller. So you have got the reaction like this. Now, once you think about the three-dimensional node, you should understand that there are 6 degrees of freedom at each of the nodes. So accordingly, this roller support will work, and where to which reaction to be released and which reactions to be restrained, that you can assign into the your structural model, and then accordingly you will get the reactions. Okay, so suppose if it is a roller, this type of loader is actually a horizontal roller, so you have got the reaction vertical, right? So vertical reaction will be there. Sometimes the roller may be inclined like this, so of course your reaction is perpendicular to the roller. Then you have got the components of the reactions. Okay, but these are related to the two-dimensional thing. Now once you go for modeling, a model is always a three-dimensional, so you have to think about the three-dimensional reactions. That means Rx, Ry, and Rz. Similarly, Mx, My, and Mz. So 6 degrees of freedom are there for each of the node. Out of that, 3 are rotational degrees of freedom and 3 are translational degrees of freedom. Now, translationals are translation in X, Y, Z, and rotations are rotation in X, Y, Z, right? So 3 rotations, 3 translations. So you can create any type of the support in your structural model, but the reaction depends on the type of the support. So where you put your restraint, there your reaction will generate, right? So if you restrain X direction movement, then the reaction will be naturally along X direction. If you restrain Y direction movement, then reaction will be naturally in Y direction. Okay, so that you should understand. Okay, so again, there is a guided roller. This may not be so relevant to your building, but sometimes this type of support will be there, where your horizontal movement is also restricted. Vertical movement is also restricted. So it can move horizontally only. So this is called as a guided type roller. And then fixed support, it is 100% restraint, where you will get reaction in X, Y direction along with the rotations and all, right? So these are the basic types of the supports. Okay, now how these supports will look like actually in the field, that you should understand. Now, these are some of the pictures where you will find the different types of the supports. Like this is first one, which is a roller type support. This is used for the bridge. You can clearly see the rollers are placed. This is purely roller, right? The second type is hinge type support. Now this is purely hinge, right? This you can consider as a hinge support, practically also, because there is a pin connection which is developed here, and whatever connection you assume for your truss design, there you either you put the weld, or there may be bolts which is more than 2, that may not behave like a pin, but this is a pin connection, purely pin connection, right? Then you have got the fixed connection. Now the difference is, you can see here there are stiffeners place, and then there are bolting. So the moments is transferred to the foundation. Moment is transferred from column to the foundation. So this will behave like a fixed connection. Then these are the general connection which is used for your trusses. You can see here this is a bolted connection. It is not a moment connection. It is a shear type connection where you have got bolts, and then only shear force is transferred through this connection. This is also a shear type connection. Here you can see the flange, means the beam is directly welded to the web of another beam. So this is a welded type connection. Here also you will get the fixity, partial fixity, but not 100% fixity. So steel structure wise, if you ask me, for industrial building, there are two connection. One is shear and one is moment connection, right? So moment connection, you should have the flanges of both of the beam, either with the beam or with the column. They should be connected to each other with the help of cover plate. Then only this moment is transferred from flange to flange. Then that is categorized as a moment connection. Otherwise, it will always be a shear connection, right? Okay, now coming to the modeling part of your structure. Now, why we model the structure? That is very important questions. Why we model the structure? Because the real structure cannot be analyzed without modeling. Okay, the real structure can only be load tested. So you can only test the structure or model of a small prototype of the structure, right? But real structure you cannot analyze. Okay, so that's why we need a tool to model, means to predict the behavior of the real structure, and that's why we are going for the modeling, right? Okay, so we can only analyze the model of real structure, right? So we cannot analyze the real structure, but we can analyze the model of the real structure, right? So model is nothing but the simulation of your actual structure. So whatever elements are there in the structure, that you will try to simulate with the help of preparing full three-dimensional model, and that is called as a model of the structure. But there are different ways of analyzing the real structure. You should understand first. So the first very precise way of modeling is a solid model. So if this is your real structure, you can see here. So this you can model a model like a solid model, where all elements, including slab, beam, walls, everything is modeled with the help of solid modeling. So this is most precise way of modeling. Even in this solid modeling, you can model the liquid also. Some of the high-end softwares are available. There you can go for modeling of the liquid if there is a water tank, right? So that is possible in solid model. Sorry. So that is the first way of modeling, which is very precise way. The second way of modeling is 3D plate frame, right? 3D plate frame. So what is the difference between this type and this type? Now here what we will do is we'll assume beam and column as a two noded elements, right? So it is it is an element having two nodes, and degrees of freedom is at the nodes only, right? So 6 degrees of freedom at each node. Like that, we will add model one element where you have got two nodes, and each node will be having 6 DOF at the end. So this is actually reduced to a line element, right? So solid element is reduced to a line element. And again, you can model a plate also at the top to represent your slab. Okay, so this is a 3D plate model. This type of modeling is mostly used in the software like ETABS, where you have got the plate type modeling, maybe membrane or shell, right? And then third type, in the same one, you can neglect this plate and you can put only a bare frame where the beams and columns will be there, but plate is not there. But you can apply whatever the loads coming on the plate, that is on the slab, to the corresponding beams, and that is the another type of the model. And these two types are commonly used in your software, right? So either you can go with this type of 3D plate frame model, or otherwise 3D frame model. So this is called as a bare frame type structure. So this type of modeling, where the plate is not modeled but beam and columns are modeled, this is common in STAAD.Pro. Okay, so STAAD.Pro will go with the bare frame type model where you actually do not model the plate, but you will model whatever the loads coming on the plate, like dead load, live load, all loads are applied on the floors. Okay, so this is a bare type, but the stiffness is not captured. Now the difference in these two types of the model is in the first one where you have got plate, the stiffness is actually captured, and stiffness of the plate is captured, and then your behavior is more close to the actual behavior of the structure, right? So this is the two ways of modeling which is most commonly used ways of modeling. The third way, which will be having low accuracy, that you can go with the modeling of 2D frame, and this 2D frame type structure you have analyzed in your syllabus. Maybe in academics, you will be having different methods to analyze this particular frame. So this is less precise method because the distribution of the moment is not carried out in third direction, which is your direction perpendicular to this paper or this plane. So the members which is coming like this is not considered in the analysis, and then you can consider the frame by frame, and then you can find out the moments. Okay, so these are the ways to model the structure. Now, where the software will stand? The software will be somewhere here, right? So these are the two types which we will use in the software modeling, and this is used for the research purpose. So if you want to have the very precise result for maybe in accuracy of 1/100 like that, if your accuracy is too much, you need accuracy, then you can go with the solid type of modeling, and there are certain software which is available for solid type of modeling also, right? But this will give you the most relevant result. Most close means actual behavior of the structure is very close once you go for this type of modeling, right? So this is how this computational model is prepared. So okay, now, the analysis technique, this slides is always, I will show you whenever my presentation is there, because this is the basic slide that is prepared. So you should aware of the types of the analysis available when you go for the software. So there are different types of the analysis. One is based on force. There you can categorize as a static and dynamic. When your force is constant, it is not changing or varying with respect to time, that is called as a static type analysis. And if your force is changing with respect to time, then that is a dynamic type analysis. The dynamic response is always nonlinear. So you can see here the force versus time is given. So force is varying like this. Your force is actually varying like this. So it is a dynamic type analysis. Material behavior, there are two types. One is linear type analysis and another is non-linear, where linear is your force and deformation is proportional to each other. That means the behavior between force and deformation is linear up to certain point. So once you know the force, you can calculate the deformation. So they are related to each other. So this is a linear type behavior, and Hooke's law is obeyed. It is within the elastic limit, of course. So the structure is within the elastic limit. There is no plastic deformation. So that is your linear type behavior. In non-linear type behavior, where the first crack developed, from that point onward, your behavior will be non-linear, and then your force and deformation curve will not be a linear one. So that is another type of the analysis based on the material behavior, right? So material can be linear or material behavior can be non-linear, but all material actually after elastic limit the behavior is non-linear. Please remember that all materials will behave in a non-linear fashion after their elastic limit, right? So to capture that behavior, the non-linear analysis is must. Okay, then only you can go for, means then only you can capture the actual behavior of that particular material. That deformation wise, it is a small deformation or large deformation type analysis. So what is small deformation? So where the material non-linearity is only considered. So non-linearity is also basically two type, material and then geometric non-linearity. So when you consider only material non-linearity in your model, that is called as a small deformation analysis. And then large deformation will consider both material as well as geometric non-linearities, right? like your soft stories. Soft story is a geometric nonlinearity, right? So you have got large forces at the soft story. So your vertical nonlinearity is there. So that is a geometric nonlinearity. If you consider both in your model, that is the large deformation analysis. And if you ask me the complication wise, this last part, which is last type analysis, is most complicated analysis. And right now, I don't know the software which will consider both one material as well as the geometric nonlinearity simultaneously, right? But the ETAB and some advanced softwares are there which will consider the small deformation analysis and geometric nonlinear, material nonlinearity is considered in the link element, right? So these are the analysis technique. Now coming to your modeling part, so you only know some of the loads, but I have shown you this list of loading which will be there in your structure. Most of the cases, these are not most of the towers, if you observe a residential tower of G plus 35 and above, you will find all these types of the loads. Some of the loads you know already, but some loads may be new for you, like refuse area, right? So this type of the area will be there when you once you go for high rise building. When I say high rise, it is a building which is above 50-meter and up to 250-meter, right, height, right? So for buildings which are above 50-meter height, you have to keep one floor after every 10 floor, right, as a refuse floor, right? So where in case of fire emergency, the people can gather there, and that floor is called as a refuse. No construction is allowed on that particular floor. It is not usable floor, so it should be kept vacant, right? And height of the floor is also restricted so that it should not be used for some other purpose, right? So height is generally 1.8 to 2 meter. So that loads you have to consider. Then some load like mechanical and electrical and plumbing services, MEP loads like pipes, and then maybe water tanks, whatever. Maybe DGs, transformers, that load is new for you. And these other loads are also there based on the architectural requirement, right? So that's it for the basic things. So we have seen some of the basic of the structure, like the classification of the structure. So trusses, cables, frames, and surface structure. Then we have seen the types of the load based on the behavior of the load, like gravity load and the lateral load. Then we have seen the types of the supports, where you have got basic three types: pin, roller, and fixed type supports. Then we have seen some of the sketches of actual roller and fixed type structure. Then we have seen this computational modeling, how this computational model can be generated for any using any software, maybe STAAD.Pro or maybe ETAB. So, and which types of the model is more accurate, like solid model and then plate frame model or 3D bare frame model, right? Then we have seen the basic classification of the analysis and then the loading criteria. So these are the all loads which are coming on the structure. Maybe some loads are included in dead load, some loads are included in live load. And then using this load, you need to calculate the lateral load, that is the seismic load. Okay, fine. Now we'll go to the actual modeling. Now for actual modeling of the building, I have taken one simple example, very simple frame. So it is not a building, as I told you, it is not an actual realistic building, it is a frame. So the reason behind it is, again, I want to show you starting from scratch to end, how this building is modeled and then how the loads are applied. So it is better to take a simple frame instead of actual building, because it will take a time to model a particular structure. So it is a simple frame. I will just explain you. We will model this frame as a G plus 2 building. So ground story plus 2 stories are there, and then there are different sizes of the beams and columns. Then the beams column sizes are varying for horizontal and vertical direction. The orientation of the column is also different somewhere. These columns are 300 by 600, and some columns are oriented like this. So we'll see how to change the orientation in the STAAD.Pro also. Then we'll generate the live load, dead load on this particular model along with the seismic load, right? So that is our target. Okay, so I will show you how to generate this type of the model. in STAAD.Pro. And before that, I will just give you an introduction to the STAAD.Pro Connect edition. Now, whenever this software is means updated or the new version is launched, the basic commands are generally same. Now, software basically works with the two types of the command. One is what you call as a GUI, graphical user interface, right? Where you need not to actually type the command, but you need to pick up the commands from the toolbar, right? So whatever the shown on your particular screen, from that screen, you have to pick up the commands. Okay, so that is a GUI environment, graphical user interface. And then another type of the command is actually typing that particular command into the editor. So STAAD has got both. You can actually type the command and you can write the command into the editor, input editor. And otherwise, you can pick up the command from your GUI environment. Both are possible in STAAD.Pro, right? Some of the software will only work on GUI environment. But of course, after creating the model, you have got the data file with you, and then you can edit that data file and then you can import that data file like your ETABS software. Okay, there you have got a GUI environment, but you can create a data file for the particular model and then you can import that data file by changing some internal commands. That is also possible. Okay, but STAAD in GUI environment only give you a freedom to give commands by typing the commands into the input file, right? So both are possible. Okay, so let me clear about this building. This building is G plus 2. So when you say G plus 2, first level is always a plinth level. So starting from where to where your model should be there, we will always model from the footing top. Okay, so your model will always start from the footing top, either footing top or middle of the footing. Based on your means practical experience, some of the structural engineer may start their model from the top of the footing if your footing depth is not much, maybe 1 meter up to 1 meter. If your footing depth is 2 meter, 3 meter, maybe raft is there and huge depth is there. In that case, you can go for modeling from the center of your footing also. Okay, so that is the first point, bottom point of your structure where your all reaction are supposed to be there. Vertical, horizontal, all reaction should be there at that particular point. So that point, either you can start with the top of the footing or maybe middle of the footing. Okay, so what will be the change if you start with the top of the footing? Naturally, your height of that particular unsupported height of that particular column will reduce. And if you go with the from center of the footing, some height will increase, unsupported length will increase, and accordingly, there may be some additional movements, right? So, okay, so we will start our model from the top of the footing, right? So depth of the foundation is more relevant. So the first story is always the plinth height plus depth of the foundation. So that is your first story where the plinth beam will be there, right? And from that, your ground stories start, and then whatever the number of stories will be there, which is there, right? So now for this particular input, you can see here the floor to floor height is given as 3.1 meter, the plinth height is 1.5 meter, and depth of the foundation is given as 2.5 meter. So the first story is 1.5 plus 2 is 4 meter, right? So the 4 meter, now I am considering from the bottom of the foundation here, right? So now, because this is just for the introduction purpose, you can decide later on from where to where your structure should be there, but that is the bottommost point where our first story height will be 4 meter, and then all other stories will be having 3.1 meter height, right? So like that we will model. The slab thickness is considered as 125 mm. So accordingly, we will calculate the dead load intensity for slab and then finishing load and all other loads, right? So that is the just an basic introduction of what we are going to model today. And then we will apply the seismic and all other loads also. Okay, fine. Now, let me share the screen of the STAAD.Pro software with you. Okay. Yeah, is it visible to you? Is it visible? Hello?
Hello.
Yeah, is it visible, this screen?
Not yet.
Okay. I think there is a lag between this. Yes, now?
नाही दिसत आहे अजून.
Okay. So I think I have to share my screen again, right? परत share करा.
Now it is visible.
Okay, fine. Okay, so this is the first screen when you start your STAAD.Pro CONNECT edition. The first screen you will see like this. Okay, so you can see here the license configuration, STAAD.Pro CONNECT edition. Then there is a first part on the left side where you have got different tabs like open, new, archive, share, and help, right? And then license and configure, right? So these are the commands on the left hand side. And then you can see here there are certain sample models available with you. The verification models are also there. And then you can always open your model where you have saved your model, right? So this week, whatever work you have carried out, or maybe last week, that is also already available here as a ready reference. So you can easily open that model without going into that particular folder. So you can just click on that particular model. That model is open for you. So all these models are available with you. Now, where to start is actually important. So first thing you need to configure is your unit system. So STAAD has got two unit system. One is metric and another is the English unit system. So both are there in the STAAD. So you need to configure your model. So for first creating a new model, just say configure. Okay. So once you put that, he will ask you what type of unit you are going to use in your particular model generation for model generation. So there is a tab like general. Okay, so language is English, and now you can see the base unit is metric. Okay, so if you keep the unit as a English one, so of course your unit will be English throughout the model. So keep it as metric unit SI system, right? Then global axis option is given here, so you can put your Y up or Z up according to your convenience. Sometimes in some model by default this Y axis is vertical axis. Sometimes in some model Z axis will be up, means the vertical axis, but you can change these global axes. That option is given in this uh, new STAAD Connect edition, right? So this basic option is there. Then there are certain other options which may not be useful. Then file format is there. Design codes is again important. So you have to set your design codes before starting your model. So steel design IS 800 2007 limit state design is there available. Concrete design IS 456 is available. Aluminum and timber, these are not used, so you can keep it as default. But of course, steel and concrete you have to change. Other codes are also available. You can see here there are different codes which is available. Even IS 800 2007 working stress design is also available, right? So for steel, you have got two options as far as IS code is concerned. Either you can go with the LSD or WSD, working stress design or limit state design. Right. Then concrete, of course, some codes are there. IS 456, ACI code is also inbuilt. American standards are there. Canadian standards are there. Chinese codes are there. Mexican is there. Everything you can get from this. But you need to configure this code before starting your actual model. Right. So this is important. Okay, so that's it. So you have to say okay for this. So your configuration is done now. So you can go for the new modeling. Just check the configuration before going for the new model. Okay, and then here he will ask you where to save your model. So there is a location and there is a file name. So this file name you can put like you can recall the type of the model. what model you have prepared. So like that, you can put the name. Here I'm just putting 3D frame, 3D frame, right? Frame, and I'm putting the date, today's date. Let's say it is 29/11/2020, right? So this is my name of the file. So remember, please do not save this file on the desktop, because once you save this file on the desktop, what will happen? It will create number of supporting file. Okay, so once you run your model, there are number of files which is created, and that's why I do not put it in on the desktop. So if even if you want to save your model on the desktop, then make a folder, and in that particular folder, you save this model, right? Otherwise, your desktop will be full. A number of files are created, right? So I will just keep this particular file in today's webinar STAAD model folder, select folder. Okay, so our model is an analytical model, unit system is metric, and then just say we have all configured this basic information, and just say create. Okay, so once you say create, this particular screen will appear. Now the thing is, you should remember the basic parameters of this particular screen generation. Okay, so for that, I just wanted to show you. Anyway, here also I can explain, not an issue. Okay, now the first tab is a file, of course. So there you can either save the file or make a save copy of that particular file. All these commands are there. Second is geometry. This is very important tab. Okay, so in this particular tab, what we are going to do is we will actually create the model, right? So geometry creation is done with the help of this tab. Now once you open this tab, there are all these are sub tabs. Okay, इसके अंदर ये वाले सब tabs है, right? So if you see this, there are grids, then structure wizard is there, then there are certain symbols like replicate, translational repeat, right? And then there is a mirror command, and there is a rotate command, then generate, rotate. All these commands are there under geometry tab. Then more node wise, it is a move command, renumber command, add beams. All these commands are there. So there are different tabs in this particular command. So this is first one, this is second one, this is third one. So this is used for adding the beams. Okay, where two noded beams are added. This is for adding the plate. Plate, as I told you, we then generally do not model the plate. Means slab we do not model in STAAD.Pro. But once you suppose if you have got say water tank अगर है, तो in that case you can go with the plate type modeling, where you need to model the all plates, means walls of the water tank, cover slab, everything. So there you can use this plate type command. Then there are solid, add solid commands is also there. So these are the basic commands in the geometry tab. Then there are view. Okay, so if you open this second tab, which is your view tab, where you will get the view of your model from different angles, right? So you can see here. Okay, इसमें once you see this top face is highlighted, that means what? This is top view. This is a bottom view of your structure, right? This is a 3D view of your structure, isometric view, right? So you can left hand side view, right hand side view, all views are possible, right? So this is very important. Then there are rotate and all here, correct? And then display whole structure. Sometimes you may have one window where you will be working on that particular window, and to close that window you just click on this particular option, so you will get the display of your entire structure afterward, right? Then there are certain graphics input like structures, color, and then tool option, display option. All this can be managed with the help of these tools, right? 3D rendering view is there, where you will get the three-dimensional view with solid fill, right? Like if you want to see whether your column orientation is correct or not, how will you check that? For that, you should go for rendering, where you will actually see depth and width of the column, in which direction there is a depth and which direction the width is there, or otherwise you can rotate your column for your convenience, for proper orientation. So 3D rendering view option is there. Then there is a select options, right? Here you have different selection option. Like if you want to select the node, then only this node cursor will be there. Once you click on this node cursor, only nodes are getting selected. Remember, okay? So even if you draw an entire window with the help of node cursor, only nodes are getting selected. Other parts is not selected. Then there is a beam type cursor, plate type cursor, solid type cursor. Each cursor will select that particular entity only, right? So if you select say beam and then you draw a window, the beam is getting selected only. Okay, so these are the select option. Again, there are certain shortcuts for selection. Like for example, if you want to select beams parallel to X, Y, Y, Z, then ZX, all these options are available. So whatever the use accordingly you can select. Then if you want to select supports, then all beams parallel to say X direction only I want to select. Let us say only X direction beams I want, then you can go for this type. If you want Y direction, then if you want Z direction, these are all the options which is available, right? Then there is a next tab, which is your specification. Now, this is very, very important, where you have got different specification, like your properties, specification for the properties, which types of beams, columns, sizing you are going to use in the structure, that is there. Then your support specification is there. Then supposing if you want to release some beam, then release specification is also there. So all the specification are in the specification tab. Then loading wise, all types of the loading will be there. Basic, there are primary load cases, and then there are the loads which is included in the primary load cases. There you can add from this particular tab. So that is your loading, wind load generation, seismic, everything is included in the loading tab. Then there is a tab called analysis and design, right? So once you go for this particular tab here, you will see the analysis command. So there are basic commands that you need to give for the analysis, like perform analysis, print, support reaction, like that. So these are all analysis command. And then there are pre-analysis command, post-analysis command. So of course this you have to use for the pre-analysis thing. So there are commands like takeoff and all. So what you want to actually want from your model, what response you want from your model. So that is pre-analysis command. Post-analysis, after analysis is completed, what you want from your model, that is your post-analysis command. And then there are miscellaneous commands also. So these are the commands. Then of course, after analysis, finishing the analysis, there is steel, concrete and aluminum and other types of design is there. So steel design, you have to set some parameters, concrete design for certain parameters, and then other types of the designing. Then there are utilities. This is another tab which is used. So in this particular tab, you can go into the command editor file. So this is your editor file where you can actually type your commands, or you can view your output. Now currently it is a locked book because this structure is not created or it is not analyzed. So you can check your output here, and you can check what are the errors in the particular models, what are warnings in the model, or notes are there. So three types you can check out after analysis, what warnings are there, errors are there. So you can remove the errors and warning. Remember, here in STAAD there are two distinct things. One is warning and one is error. Error is the thing that you must remove, right? So when you get the error in your model, that has to be removed, that must be removed, otherwise your model results are not available, right? So but warning, of course, you can neglect. Certain warnings are there that you can safely neglect. For example, the floor load transmission, because we are assuming that your two-way load transmission, and sometimes if the panel dimension is like one way, there you can have two options. Either you go with the two-way things, उसमें भी कुछ ज्यादा फर्क नहीं आता है. Even if you go with the two-way things, The load is always be there on the shorter sides, but of course the loads is very, very less transferred to the shorter side. Okay, so that may give you an warning that if the floor load generation has one way or two way definition. So there you have to check whether this warning is relevant to you or not. Sometimes there are notes also, that also you can neglect safely, not an issue. But just read that note. What are that notes? Okay, so these are the things that you will get in the output file. In command find, of course, this is very important, and once you type the command in the file, and if that command is wrong or something is wrong in that particular command, automatically when you close this command file, at that time only the software will report the error, okay, even before running the analysis. Okay, so there only you can check whether your commands are correct or not. Okay, or something is missing, then you can actually go into the depth of that particular thing, and then you can resolve the things. This is very good thing related to the STAAD.Pro. Before analysis, he will tell you everything, where your model is correct or not. So if you ask me for other softwares like ETABS and all, there after analysis only you will get the report, and then you have to interpret it whether your modeling is correct or not. Of course, there are certain options available like animations and all, or maybe you can go into the editor where you can check out the errors. But instead, immediately you will get the error, right? If something is wrong, immediately you will get the error, right? Okay, I think this command, whatever I have shown you, it understand, means you have understood this. And now we'll go to the modeling. Okay, so you know this modeling, you have to start with the geometry, and then this is the geometry tab, where on the right hand side you will see the formation of the node. Now here, once I say the geometry, the creation of the geometry can be done in n number of ways. You can create your geometry in any suitable way as you desire. It is not a fixed way of creating the geometry. So sometimes the geometry may be complicated. Sometimes geometry may be very simple. Okay, so the creation of the geometry for the particular structure, you can go with as you desire. There is no particular way of creating the geometry. For example, I can create the node, I can join the beam in between the node, and then I can replicate in X direction, or I can create all columns in the X direction and then I can replicate in Y direction, like that. So there are number of ways of creating the geometry. There is no one fixed way of creating the geometry, but you should think about the reduction in time. So timing is again a concern. So you have to create the model fast, then shortcuts you have to adopt, how fast you can create your model, right? Like that you have to think. But there are number of ways, but now for this particular model I'm going very slow, so that you can understand each and every step of the software, right? Okay. So first what I will do, I will just create a single node where you have to give the coordinates of that particular node, right? Node is nothing but a single point in the structure having 6 degrees of freedom, 3 translational degrees and 3 rotational degrees. So I will just create one single node on this particular platform. Okay, so let us say we will start our model from 0, 0, 0. So 0, 0, 0 is my first coordinate. Okay, so let us input this value 0, 0, 0. Right, you can see the node here. One node is generated. So this black point is nothing but your node of the structure, right? So one point is generated. Now what I want is I will just create one column with certain nodes, right? And then I will replicate that column along X direction and along Z direction. Remember, our Y is vertical. Remember, our Y is vertical, and Y vertical, positive is up and negative is down. Positive is up, negative is down, right? So like that you have to give the coordinates, right? So if you want to create the node below this node, generally you have to put the Y as negative. If you want to create a node above this node, then Y must be positive, right? So like that you have to keep the coordinates because they are coordinate, right? So coordinate means you have to think about the sign also, positive or negative, right? So here I am just putting one node as 0, 0, 0 coordinate, and then my next node, as I told you, this is my bottom point of the structure, which is your point of connection between footing and your column, where your fixity will be there, right? So this point will assume as a fix, and here there will be 2.5 meter depth of foundation and 1.5 meter as a plinth height. So my first slab means, or first plinth level will be at 4 meter from this point, right? Okay, so I will just show you that plan once again. Is it visible to you, PPT? Hello?
Yes,
I
sir.
think
Yes,
I
sir.
have to share. PPT is visible, no?
Yes, sir.
Yes. Okay, fine. So here you can see this is to 1.5 meter as a plinth height and 2.5 meter as a depth of foundation. If you add these two, you will get 4 meter, right? So 4 meter is my next node that I want to create. So the coordinate of that particular node is 0. So y is up positive. So I will put 4 here and then again a 0, right? Z is 0. Z is 0, right? So this is my first node. Now from here after, this is the level. Which is this level? This level is nothing but a plinth level. What is this level? This level is nothing but the connection of foundation with your column, right? So these two levels are created. Now I will create the levels above this. So first level is a ground level, which is having a height equal to 3.5 meter. So let us put 0 here, and here I will put 3.1. Not 3.1, it is an incremental distance, so it is 7.1, right? 4 plus 3.1 will be 7.1, and again the next coordinate will be 0, right? Okay, so that is the next node. Now the next node will be after 7.1. Again I have to add 3.1. I'm just modeling this G plus 2 building. Yes. So there are two stories. One is ground story and another two stories. Okay. So G plus 2 is our target, right? So this is G now. 7.1 level is ground. Now I'm just adding this 7.1 plus 3.1, that is 10.2 will be my next level. So it is 10.2. Okay. And then again Z equal to 0. I'm just creating one single column here, right? Now again the next point will be again 3.1. It is 13.3 level, so it is 0 plus 13.3 and then 0, Z0, right? So let us check whether our all points are there or not. For that you just go to view, 3D view of the structure. Okay, is it visible to you? I'm not seeing any addition points. Just close this. Okay, I can see only 3 points here. Yes, is it visible to you now? All 4 points, 1, 2, 3, 4, 5 points.
Yes, it is visible.
Yeah, so now what we have done is actually we have created these 4 points only. Now again I'm just telling you that this is your fixity level, this is your plinth level. This story is the first story, which is your ground story, then your first story, and then second story. So G plus 2 stories we have created. Now as I told you, this is not the only way of modeling. There are a number of ways, but I'm following one simple technique. You can understand it properly. Okay, so what I will do now, I will just connect this and then will form a column by connecting. For that you have to go to geometry and then add beam. Add beam option is there, so you can click on this particular option where you will get the beam cursor. Okay, like this. Now you can see my symbolic change. Okay, जो आपका कर्सर है उसका सिंबल चेंज हो गया है, राइट? सो इट इज नाउ अ बीम कर्सर. right? So you can click on this particular node and then you can add your beam like this. Okay, now I'm creating a geometry for adding the beam. Now this beam is added, or you can call it as a column, of course. It is a two-noded element, whether you call it as a beam or column. Ultimately, when you go for the design command, then only you can specify whether it is a column or beam. So now this particular column is created. Okay. Now what I will do is I will just replicate this particular column along x direction and along z direction, right? Y is vertical. Y I have already created. Now you can replicate along x and along z. Along x and along z. Okay. So along x I have to put the positive distances. Along z I have to keep the negative distances, because I want this as a first column. Then all other columns will be in this particular direction. So I want to keep this distance as negative for z direction. For x direction it is positive, right? So for that, what I want to do is just select this particular element. You can draw a window like this. Okay, all these nodes along with the column is getting selected, and in the geometry tab you will find this small symbol here. This is a translational repeat symbol. It is nothing but the copy paste, okay, or replicate. Okay, so translational repeat. Okay, so if you click on this, he will ask you where to replicate this particular column with the nodes, right? Whatever you have selected, that all is getting replicated or copy paste. Okay, so I have selected the nodes and the beams or the columns, and then I want to replicate this in x direction. So global direction I have kept x, and how many steps you want, that depends upon your spacing. Now I am creating, can you see this PPT? Now I have created this particular C1 column. Now what I am going to do is I will create C3, C4 and last C1 column. Okay, so the spacing will be 3.5, 2.5 and 3 meter. 3, 3, 2.5 and 3. So these are my step spacing, right? So I will just click here. I want 3 steps, right? The first step is having spacing equal to 3 meter. So I will just keep 3. Then the next is 2.5 and then again 3. Correct? So 3 steps will be there. The first is 3 meter. Second will be 2.5. The third will be 3 meter. Right? And I want to replicate in x direction. So x direction is on here. Correct? And then there is a option called link step. What will happen if you click this option, this nodes that you have created in between this column, they are connected with each other with the help of beam automatically, right? You need not to draw the beam. Okay, so I will just keep this link step option on. So click on link step and say okay. Now remember, this direction is very important. Please be sure that whatever direction you want to replicate, that is on, otherwise it will be replicated in some other direction, right? So okay, and this is default spacing. If your all steps will be having same spacing, then this option you can use. Otherwise you can put your actual spacing of the steps here, right, and say okay. Okay, now you can see in three-dimensional things, this beams and columns are created. Okay, now what I want is, I don't want this beam. This is at the footing connection level. This I don't want. So you can delete it later on. So you can select it and just press the button delete. Okay, so I don't want these three beams. Okay, so this is deleted. Now see here, this is how your structure will look like as a plane structure now. Now it is not a space structure. Three-dimensional is not there, only plane structure is there. So here, this is a fixity level, this is your plinth level, this is your first slab level, this is a plinth level, and then this is the first slab level, and in between that, this is your ground story, this is your first story and the third story, sorry, second story. So ground, first and second, G+2 building, very simple, right? Now I have created the geometry in x direction. Now same geometry I'm going to repeat along z direction. Okay, so for that, again I will just keep this window like this. Okay, so now all beams and columns are selected. Now I want to replicate this along z direction. Again, same command I'm going to use, which is translational repeat. Okay, Again, how many steps you want, right? So for that, let me show you this PPT again. So here I want a spacing equal to 3.5 meter and 3 meter, right? 3.5 and 3. Okay, so only two spacings are required. So go back to your model. So here I will just keep two steps, right? First step spacing is 3.5 and second step, sorry, here I have to keep minus 3.5. Remember, now I'm going to repeat in this particular direction. Okay, so this is 3.5 minus and second is minus 3. Correct. So two steps are required, and do not forget to change the direction. Now I want in Z direction, right? So Z axis is to be selected. Global direction is Z. Number of steps is 2, right? And again, I want to link the step in other direction. Also, I want the beam, so I'm going to link this step. So minus 3.5 and 3. So steps are linked, and then it is in global Z direction. So say OK. Okay, now your structure is ready, three-dimensional structure. Again, in this particular direction, I don't want this beam. So for that, what I will do is I will go to the view command and then just check this view, which view these beams are there. Yes. So these are the beams which we don't want. So just click on this particular beam, click on this particular beam and say delete. Now remember in STAAD, there is one more thing you need to remember, that whenever you on any view, the beams which are there on that particular line is all beams and columns is getting selected. For example, if I go to the top, okay, I will show you what I mean. Okay, suppose this is the top view of the structure. Now supposing if I select this particular beam at the top, ये एक ही beam select नहीं होगा, only one beam is not getting selected, all beams below this particular beam is getting selected. Now if you want to check whether it is true or not, just click on this particular beam and now I will go to the 3D view. Okay, now see this. Okay, all beams are getting selected. So be careful when you are working on the plan, and if your entire structure, whole structure is displayed, and once you click on that particular beam, all beams are getting selected. So if you do any modification to this particular beam, this is applicable to for all beams. So be careful while using this particular view option. Okay, 3D there is no problem. 3D may whatever you select, that will only be selected like this, but in plan and other views you have to be careful. Okay, so now because I want all beams, so there is no issue at all. So I will just check this view. Okay, yes, select these two, control दबा के, and then say delete. Okay, delete. Okay, so now my three-dimensional frame is ready. Simple frame. Okay, so now this is called as a creation of geometry. Now I am just creating the geometry for the particular structure. Nothing is, no loads is applied on the structure. No member specification is given. No material specification is given up till now. Okay, only simple geometry is created, right? Now, this geometry you can create in number of possible ways, as I told you. Okay, so some may desire, some may want that he will create the entire plan first and then replicate in y direction. That is possible. It may be a simple method. It is possible. No problem. Okay, somebody may create all beams, all columns in one particular plane and then replicate in other plane. That is also possible. Only thing you need to ensure that all nodes are connected at that particular point. There should not be any discontinuity. That is the first thing you need to check. The second thing you need to check is there should not be overlap. Okay, there should not be two beams at the same location. Okay, otherwise this model will throw error, right? So there should be single beam or single line element, and then all beams should be connected with each other with the help of node, right? So that you need to ensure. Okay, otherwise you can create your model in whatever way you want. Okay, so that is about the creation of geometry. Now the next step is to assign the load and then the properties to this particular beam. So before going for load, we will assign the material for this particular frame. Okay, material is not defined. Okay, material is not defined. So we'll go to the material first. So let us go to the material. Okay, now by default, if you see on this particular window, by default, there are certain materials which is already available. You can use this material or you can edit this material with the help of edit command. Okay, so now I am going to use the concrete for this. So just click on the concrete and say edit. Now you will see here other properties are locked here. You can put compressive strength of the concrete only. Okay, so here you can specify the compressive strength of the concrete you are going to use for the design purpose, right? So let us use this M30 concrete. So M30 FCU value, compressive strength of the concrete is 30,000 kilonewton per meter square. Remember, unit is already set. Okay, now we are doing this in kilonewton per meter square. So it should be 30,000 kilonewton per meter square. I'm just putting this value as a 30,000 kilonewton per meter square. Say okay. Now concrete strength I have changed only. Now other things I kept same. Now if you want, you can go to the STAAD editor and you can change your other properties of the concrete. Like for example, if you want to use say E value, which is 5000 root FCK, you can change that value here. By default, this E value is there. This value also you can change, but that is in editor. I will show you later on how to change this E value if you want. Otherwise, you can keep this same value. Okay, so other properties like Poisson's ratio, which is 0.3 for concrete, that also you can change. Density is now currently it is 23.5, you can put it 25. So these properties you can change in STAAD editor where this concrete is defined. Okay, so I will show you later on to how to go to the editor and then change these properties. Anyway, now I will just keep this concrete as a material for this particular structure, and the strength of the concrete is considered as M30, which is 30 kilonewton, 30,000 kilonewton per meter square, which is 30 Newton per mm square, right? So that is your concrete. Now, the next step is to assign this whole model, this material, okay, and along with the properties, right? So just go for the definition of the properties, right? So for that, in the same thing, you will find the properties specification. So go to the properties. Once you open that, here you will find a window where you can define your properties of the structure. That means what? Properties means dimensions of the structural elements like your beams and columns, right? So now let us go back to our PPT and let us check how many beams and columns we need to define. So is it visible to you, PPT?
Yes, sir.
Okay, fine. So I will just make a full screen and then, yeah. So you can see here there are three types of column we are going to use in the structure. One is 300, 600, another is 450 by 450, and then another one is 350 by 350. So these three columns we will define first. Okay, so let us go back to our STAAD again. Okay, so we'll define three types of the columns. One is 300, 600, then another is 450, 450, and another one is 350, 350, right? So for that, you go to the define command. Here you will find whether your column is circular or rectangular. I want rectangular. Now this is YD. YD is the depth, and then ZD is a horizontal dimension. So YD is 0.6 and ZD is 0.3. Correct? 0.3 by 0.6. Material is concrete. So we have kept that default material as it is. We have only changed the characteristic strength of the concrete to M30. So material is same, and just say add. Okay, once you say add, then this material property is getting added into your list. It is not assigned to the member. It is just a list of the material. Okay. Now the second is I will keep 450 by 450 as a column, 0.45, 0.45 say add, and then last one is 0.3 by 0.3 say add, right? So all three properties are added. So that's all for the column. Say close. Now we'll look at the beam. So how many types of the beams are there? Now if you can see here, there is 300 by 600, 300, 400, and 300 by 450, right? So 600, 400, and 450. right? Three types of beams are there. Okay, so let us go back to this thing, model. So let us add the beam. So again, go to define concrete. So 0.6 by 0.3, then 0.3 by 0.45, say add, and 0.3 by 0.4, say add. Okay, so all these beams, so these three are beams. Okay, these three are beams, 1, 2, and 3, and these three are columns, 1, 2, 3. So 3 beams and 3 columns are getting added. So total 6 properties we have with us now. All properties having material equal to concrete. Now remember one thing, when you assign these properties to this particular model, first you click on the property and then you select that particular member where you want to assign this particular property. Okay, so once you supposing if you go in the reverse way, suppose first you select this member and then you select this property, then this member is deselected. Okay, so again you have to select that particular member, right? So first select property and then select member and then go for assign, correct? So that is the correct sequence. Okay, so now I want to assign this rectangular column of 300 by 600 to the particular columns. Okay, so where is this 300 by 600? That we need to check first. Okay, so all these 4 columns, 1, 2, 3, 4, last row, this all 4 columns are 300, 600. These 2 corner columns are again 300 by 600. Okay, so total of 6 columns which are 300 by 600 dimensions. Okay, so for that the better way of assigning this is to go to plan view. So view, then say plan. Now I am in a plan view, so it is better to select from plan view. Okay, so how to select this? So first you need to click on the properties as I told you. Okay, so I am just assigning this property. So click on the property and then go for selection. Now you draw a window like this only. Okay, so you will see this single small point here. So this entire column is getting selected. No other beams is selected. Okay, all columns is selected now. This entire column is selected. Okay, and then say control, press control and select other nodes also, other columns also, like this. Okay, so this 4 I want 300 by 600, along with this 2 should also be 300 by 600. Direction wise, rotation wise, we'll see later on. We'll rotate it, no problem. Okay, so this property is selected, and here you will find different option: assign to selected beam, assign to edit list, use cursor to assign, and assign to view. Assign to view means all structure, whatever the structure is there, entire structure, these particular dimensions are assigned. Now I want to assign this particular selected entities only, right? So I will just click on this option. By default it is there, assign to selected beam, and say assign and then say yes. Okay, so now this property is assigned to this particular columns. Okay, now go for the next assignment. The next assignment is the center column, which are C2, which will be having dimensions equal to 350 by 350, right? So 350 by 350 center column C2. Okay, so that we will assign. So just click on, I think that we have kept this 300 by 300. It is actually 350. Okay, so let us change this. So make it 350 by 350, 0.3535, change. Okay, so this I want to assign to the center column. So select this particular column and then go for the same method. Draw a window here like this, small window. Okay, and just say assign. Okay, now this is assigned to this particular columns. Now remaining are these 2. Of course they are 450 by 450. So click on this property, 450 450, select these 2 and say assign. Okay, now you can check it in the 3-dimensional view. Okay, so these all column properties are assigned. So if you click on this, you will find that whatever the properties you are assigned, they are getting highlighted. So there is a command here, tick highlight assign geometry. Now this is R1 property, this is R2 properties, and this is R3 properties, right? R1, R2, R3. These columns are assigned. Now we'll go to the beam. Now how to assign the beams, right? So for that, we'll again select the plan. So that will be the better way of assigning. So now this horizontal beams and vertical beams are different. You can see here the horizontal beams are 300, 600, vertical beams are 300 and 450. Okay. So let us check this. Select this horizontal beam. For that, we need to horizontals are 300, 600. So first you click on the property 300 by 600 and then select this horizontal beam. Just click on this center. So it is getting selected. Now remember, this is not only one beam which is selected. All beams below this particular beam are selected. Okay, so everywhere you can assign this property. Okay, say assign, yes. Okay, now vertical beams are 300 by 450. Okay, so select this property 300 by 450. Okay, select this vertical beams. And say assign. Okay, now it is done. Now one more beam is there in between here that we have not modeled. So let us model this beam first. Okay, and then we will replicate to the other levels. Okay, so all levels there is a secondary beam like this. Okay, so this distance is not given. It is 3.5 here. So we'll consider this as a 1.5 meter. So let us model one beam at 1.5 meter. Now I just wanted to model this beam on the top level only. Okay, so how to model that I will show you, because now once you go for the plan, this is whole structure is displayed here, and if you model this beam, this is for the entire structure. Okay, so I just wanted to model it on the one level, suppose. Okay, of course I want it on all levels, but I just wanted to show you that when you want to work on a particular level, how to work. So for that, you go to any side view. Okay, and then just keep this window like this. Okay, so only this particular level is getting selected, and say right click and say new window. Okay, and here you say create new window. Okay, and say okay. Now here you can see that this is a new window which is created where you can find only top level. Okay, here it's only a top layer. Now you can go to plan and then you can safely model wherever you want. Okay, so I just wanted to show you this command. So how to work on a particular level, right? So this is top level now. Now here I will model this particular beam at this level, and then we will replicate that beam to other levels. Okay, fine. So let's do this. So for that, again, what I will do is there are two ways you can replicate this beam here. Okay, this beam here at a particular distance so that the nodes is automatically created. One way of doing that, or otherwise you can add a node here and then you can model the beam. Okay, so how to add replication is already done, that you already seen. You just need to select this beam and then say replicate in Z direction. Okay, so you can get that beam here. Okay, so other way I will show you, that is not covered. So go to again geometry. Okay, say add beam. Okay, add beam command is already and here anywhere you can click on, so that he will ask you where to create the node. Okay, so suppose if I click here. Okay, so he will ask you, do you want to add a node here? Say yes. Okay, now I want to add a node here. Where to add the node? Whether you want a midpoint or add a new point at particular distance. Remember, this is from one of the ends, so I will just randomly this keep it as 1.5 meter. I don't know from where it will take, maybe from this node or maybe from that node, but anyway we'll keep 1.5 meter here, and then say add a new point. Okay, so this new point is created, you can see here, and say okay. Okay, now see here, this is a new point which is created 1.5 meter. Similarly, here also you can create a new point with 1.5 meter distance. Okay, and say add new point. Okay, and say okay. Okay, now here you can connect like this. Okay, so this beam is connected. Otherwise, you can replicate this also, not an issue. Okay, now this is created on the one of the level only, not all levels. Okay, but I want it on all levels. So let us replicate this in all levels. First, we'll assign the properties and then replicate. So for that, let us select this beam and sorry, first select this property, then select this beam and then say assign. Okay, now this property is assigned. Now I want my whole structure to be displayed. So for that, go to view and say display whole structure. Okay, now you can see that this beam is only created on one level. Okay, not all levels. Okay, so it is at the top level only. Now I want to replicate this beam on all levels. So for that, just select this beam, go to 3D view, and then where you want to replicate. Now I want to replicate this on this and this level. All are 3.5 meter height along y direction, and then these are this need not be linked, but I want just replication. So go for translational repeat. Here I will select y direction, and this is negative y, so it should be step spacing will be minus. So 1 2 3 steps I want. So it is 1 2 3, and all steps I want the spacing, either you can put here spacing as minus 3.1. okay, negative 3.1. I don't want to link this step. Okay, direction is y, so minus 3.1 means replicated below this particular beam. Okay, so say okay. Okay, now this beam is created on all level. You can check. So how to check whether this beam is on for all levels or not? So again, go to any side view. Let us check whether this beam is created here or not. Okay, so I will just select this level, isolate it. Okay, and then go to plan. You can find this beam. Right, so this beam is there for all levels. Anyway, now this is how this geometry is created. Now geometry is created, material is assigned, member properties are assigned. Now the next part is to load generation. Next part is load generation. For that, what I will do is before going for load generation, I need to assign the specification. What is that specification? Because this is a secondary beam, I need to release this at this end and this end. It has to be released at both end. Okay, so I want moment to be 0 at both ends of the beam. So for that, I want to release this. So let us select this beam. Now you can see this all beams are selected here. Okay, go to specification. Okay, and then I will add the specification for moment release. I want this beam to be released. Okay, so for that, you go to beam. Okay, here you will find start and end release. Okay, so releases are here. These are reactions, these are moments. Reactions I want, but a moment I don't want, so I will release the moments. So which moments is to be released? Mx and mz. Y is vertical, right? So mx and mz to be released at start and end. So start, say mx and mz. Okay, say add. Again go to beam, then end, say mx and mz, say add. Okay, and then you need to assign this to particular beam. Say assign yes, then end also say assign yes. Okay, so that's it. So now it is release. Now material properties are also assigned. One more thing is required, that is support specification, which is very important. So go to supports. Everything is there in specification. So go to support. Now currently there are no supports, so we'll create one which is fixed support. All three directional translation is restrained, moment is also restrained. Say add, and then I will add this to your supports. For that, you need to go for this support node, and then just select these nodes and say assign yes. Okay, support is assigned to this particular model. Okay, it's a very simple model, so simple to create this geometry, but there are certain things that you will find little bit difficult afterward when you start defining your loads. Okay, so this geometry is created. Now what I will do is I will just assign the loads here. Okay, so go to loading here. Next command is loading. Okay, So geometry is defined, material is defined. Now I want load to be assigned. Now remember, in equivalent static analysis, I think we are running out of time. Whether it is correct, it is 12:52. Anyway, okay, we'll continue. Okay, so we have to assign the loads. So top floors, there are specification in IS 1893 that roof loads should not be considered in the seismic weight, and all other loads, live loads, should be considered in their proper proportion, right? So first we'll assign the dead load and live load to the structure, and then we'll define the seismic load. But the STAAD wants that your seismic load to be defined first. Okay, so anyway, but first we need to define the seismic load to this particular structure. Now we are doing this equivalent static analysis. Okay, so now I will show you how to assign the seismic load to this particular structure. Okay, so let's do it first. So first is the definition. So if you open this definition, you will find there are different definitions which is available. One is vehicle definition, time history definition, wind definition, snow, and then seismic. Okay, so seismic, select seismic. Okay, seismic is selected. Now say new. Okay. Now here you will find that the seismic load parameters will be there. Now I want to generate the seismic load based on IS 1893-2016. Okay, so just change this code to IS 1893-2016. Okay, it is inbuilt in new version of your STAAD.Pro. So it is 1893-2016, right? And then just say generate. Okay, once you say generate, you will get into the seismic load definition. Okay, so city, the city I will keep as Mumbai. Okay, so I want to generate the load for Mumbai city. So say Mumbai here. The zone factor is automatically selected. For Mumbai, it is 0.16. Then response reduction factor. So this depends on what type of frame you are using for your structural analysis, whether it is a steel frame, whether it is RC frame, whether it is RC with brace, whether it is RC with shear wall, whether it is special moment resisting frame or ordinary moment resisting frame. Ordinary, special, there is a difference. When you say special, this IS 13920, that is your ductile detailing is followed, and when you say ordinary, this 13920 is not followed. Okay, so there is a big difference between this ordinary and special moment resisting frame. Once you go for 13920, there is a term called strong column and weak beam that has to be ensured. So software will automatically ensure whether it is strong column, weak beam theory is applied or not. That means what? If your capacity of the beam exceeds the capacity of the column, so column will show, software will show your column as a failure, right? So that is about the special moment resisting frame. Capacity of the beam should always be less than capacity of the column at the joint, okay, at a particular joint. So when it will happen, supposing let us say if your column dimension is 300 by 300 mm. I will just give you an example. If your column dimension is, let us say, 300 by 300 mm, and over that column, if you put a beam equal to, let us say, 300 by 800 or maybe 1 meter depth, 300 by 800 or 400 by 800 or 400 by 800, like that. 400 is not possible because column dimension is 300 mm. So of course width should be 300 mm. So if you put a beam on the column of 300 by 300, and over that if you keep the beam equal to 300 by 1000 or 800, naturally your beam is stronger than your column. Okay, and even if you put the maximum percentage of steel in the column, that is 6% as per IS 456, then also your column capacity will be less than your beam, because your dimensions are less, correct? So in that case, this software will show you that your column is failing, correct? So that you need to ensure whether which type of frame you want to use. So here I will keep the frame as a special moment resisting frame with response reduction factor equal to 5. Okay, so that is your response reduction factor. Now the next thing is you have to define the importance factor. In new IS code, IS 2016, there are 3 types which is there. One is your important building, another is residential or commercial building, and all other building. Previously, there are in the older version of your 1893, that is 2002, there are only two types which is defined, that is important building and other buildings. But here there is one more term which is introduced, that is residential or commercial building, where the factor is allowed equal to 1.2. If your building is residential building, this important factor you can use 1.2. Once you select this residential, you will find that here the factor is 1.2. This factor is newly introduced in 1893 2016. Previously it is not there, correct? So anyway, but we will consider this as a important building with 1.5 factor. And then type of the soil, I will select medium type soil, and type of the structure is RC, moment resisting frame building with 5% damping, right? And then say generate. Okay, once you say generate, this particular data is recorded here, and then say, just say add. Okay, now your seismic load definition is done. Now remember, this is only a seismic load definition. It is not a load. We need to create the load, right? So how to create the load? So there are two ways of generation of the seismic load. That first method is always, what you do is, you can add the load here, like using this command, or you can go for the STAAD editor also. Okay, so I will show you both one. So how to add the load from here and how to use the STAAD editor. So here, if you want to add the load, say add. Now these are the loads which is called as a seismic weight of the structure, not the loads. So whatever the loads you are assuming for your structure, like dead load and live load, the seismic weight is different. Okay, you have to consider the full dead load, that is one, and the portion of the live load. So how much portion of the live load is considered, that depends on the intensity of live load. If your intensity of the live load is up to 3, up to and including 3, you need to consider only 25% of the live load as a seismic weight. And if your live load intensity exceeds 3, the 50% of the live load to be considered. That is defined in 1893. Okay. So accordingly, we will define this load here as a weight. Okay. So okay, fine. So let us define this. The self weight is with one factor. Here there you need not to define any direction. Direction is not required. Only just put the factor. Self weight one factor means the self weight is added. Say add. Then we will go for the floor weight. Okay. So now here it is important. So self weight of the slab is 3.5. We will add 1.5 as a finishing. So the total self weight of the slab comes out to be 3.5. 3.5, how it is work out? I will just show you this PPT. Is it visible to you? Is it visible to you?
Yes, sir.
Yes,
Okay.
sir.
So yes, so self weight of the slab is 125 mm into 25 is a unit weight. So 0.125 into 25 is 3.125. And then I have considered 1.5 as a finishing. So 3.125, because we are not modeling any plate. So the self weight of the slab is to be considered. So 3.5 plus 1.5 will give you 4.625 as a dead load of this particular slab. Okay, so we'll add that dead load as a seismic weight, because we have to consider the entire load. So just keep here 4.625, correct, kilonewton per meter square. And where to where it is at, so here you have to specify the range. Okay, there are three options: Y range, X range, and Z range, correct? So I want that this load to be generated from all for all levels. For all levels, it has to be 4.625. Now remember, the live load on the roof is neglected, but self-weight is not neglected. So self-weight you can always add, okay, in a seismic load definition. So self-weight is, it has to be there. So what I will do is just, I will just check. I will just select this node, and I will just check the coordinate of this particular node. The coordinate is 13.3 meter, correct? Y coordinate, and here it is 0. Okay, so 0 to 13.3, you can generate this load. So all levels will be having load equal to 6.4.625. So just keep minimum as 0 and maximum as 13.3, right? And say add. Okay, now this floor load, that is del load, is added to the seismic weight. Now the remaining load is your live load, right? So live load, for that I will specify in two parts. One is the loads which is there on this and this floor, and roof we have to neglect, so we need not consider roof. So only three levels you have to generate. So for that, your live load intensity we have to check. So live load intensity is considered as 2 kilonewton. So 25% of that will be 0.5. Okay, so only 0.5 live load you have to consider for seismic weight, 25%, because live load intensity is less than 3. So only 25% of the live load to be considered, and that in the y range of up to this only, correct? So I will check the coordinates of this point. It is 10.2 meters. So I will generate the live load up to 10.2 meter only. So 0 to here I will check 10.2, and then live load intensity is 0.5. Say add. Okay, so these two loads are added in the structure as a seismic weight, and then self weight is added. Now remaining part is your intensity of load on the beam. So beam, because it is a bare frame model, so wall loads you can add here. Wall loads you can add in the same way as the loads which is added for the floor, but the only thing is you need to add it as a weight. Okay, so here I will just show you. I will not go into that particular thing. So say add. Here you can see here member weight is there, correct? Member weight. Okay, there are two things. One is concentrated and then uniform. So say member weight, uniform, and then just add the wall weight here. But wall weight, once you add, you have to assign it to all levels. So I will just add this wall weight uniform for all three levels here, 1, 2, and 3, and top level, because parapet is there, this weight is different. So let us assume that your beam dimension is 300 by 450. So your clear dimensions of the wall will be 3.1 minus 0.45. That will be 2.65. Okay, so how wall weight is calculated? I think I have shown you here. Yes. Yes, it is there. Okay. So can you see this PPT? Yeah.
Yes,
So
sir.
here, okay, so wall load on the beam is 3.1 minus 0.45. This is clear height of the wall. The 18 is unit weight of this particular material, that is block work. And then 0.2 is the thickness. So 9.5 kilonewton per meter is a wall load on the beam. Of course, the roof, it will be different. Roof may, there will be only parapet. So we will consider that as a 3.5. I just wanted to show you how to add this weight. So this is 9.5 and 3.5 I'm going to add for wall. So just say member weight uniform. Now here the thing is, instead of adding here, I will show it in an editor. It is better to add it from editor, because uh, it is for the different beams. Otherwise you have to give all beams here. Okay, you have to assign this load to all beams. Okay, anyway, but that I will show you in editor. Okay, so this is about the seismic load definition, where we have defined the parameters, the self weight of the beam, all material means all structure, then the floor weight, which will consist of dead load and live load, portion of live load. Okay, the only remaining thing is member load, that I will show you in the editor. So it is better to add it in an editor, jaldi ho jata hai. So anyway, so that's all for the seismic definition. Now we'll go to the actual load cases. This is not load case, it is a definition, remember. So we have created the seismic definition, not the load case. Now we need to create the load case here, correct? Okay, so for this seismic definition, we will create a new load case. Okay, so here go to load case. Okay, so once you go to load case, I will just create a load case for the seismic load. and say here the name of the load is, let us say, EQX, earthquake load in positive X direction. So EQX positive. So I have to create 4 load cases: EQX positive, EQX negative, EQZ positive, and EQZ negative. Y is vertical, right? So only 4 load cases to be created. So I will just say EQX positive, say add. Okay. Then next will be EQX negative, right? Say add. Then EQZ positive, say add, and EQZ negative, say add, correct? So all load cases you can see here, these are the creation of the load. No load is assigned in this particular case right now. Okay, so we have defined the seismic load. Now why we are defining the seismic load first? Because it is the requirement of STAAD. Okay, STAAD wants that your seismic load definition should come first and then all other loads like dead load and live load. Okay, so that's why we are defining the seismic load first, and then we will define the other loads like dead load and live load. Okay, so now I will just click on this particular load case and then say add. Now I am going to add the load here. Okay, seismic load. Now here you need to go to the seismic loads. Okay, and then you have to put the direction only. Now it is in the X direction, EQX case. It is EQX case positive, so it is positive 1 factor. Okay, and say direction seismic load with factor 1 and say add. Okay, that's it. Okay, so here this 1893 load is automatically created. Now go to negative, again say add. Okay, and go to the seismic loads. Here you keep -1 X direction factor as -1, say add. Then go to the next one, Z, say add. Again go to seismic. Here go to Z direction, say 1 factor, it is positive Z, so 1 factor, say add. And the last load, which is negative Z, say add. Go to seismic load and Z direction, say -1, say add. Okay. So all these loads are created. Seismic load in positive X, negative X. Only member loads are still need to be added in seismic load definition, that we will see. Okay, so this is how these loads are created. Now we will create one more load case, two more load cases for the other loads, that is dead load and live load, and then we will apply it to the structure, correct? So say new, or you can say add also. So it is a primary load case, that is the case number 5, and then we will say this as a dead load case. So say dead load, sorry, primary load case, say dead load, and the type of the case is dead. Okay, now dead load is created here. Now I will just create the live load similarly. Case number 6 is live, say add. Okay. Now other two cases are created, 6, 5 and 6 are dead load and live load. So in dead load, now I will add the loads. Now these loads, whatever you have created, is for the seismic load definition. It is nothing to do with the dead load. Okay. So now we are adding the dead load in the dead load case. Okay. So again, our total load intensity for the floor will be around 3.125 plus 1.5, right? So 3.125 plus 1.5 is around 4.625, same. Okay, so 4.625 dead load I will add for all floors, which will include wet of the slab and finishing of slab. Okay, so just say add, and then here, sorry. Okay, say load atom. Now I want to add the floor load. So go to floor load. This is in Y range. The intensity of the load is 4.625, and I want it in the global Z direction from 0 to 13.3, all floors, right? 13.3, 0 to 13.3, all floors. Okay, say add. Now, once you add, you just click on this and check whether this load is generated or not. Here you can see the value. This load is properly generated on all floors. Okay, so dead load is done. Now in dead load finishing, this include finishing as well as the sulfate of the slab, remember. Okay. Now dead load, now here I want to add the member weight. Sorry, this wall load on this particular beam. Okay, now here only you can add this wall load on the beam. Okay, now how much is the wall load? There are two types of the wall load. One is for parapet and one is for other floors. Okay, so we'll create two loads. So go to this particular load items and say member load. Now what I will do is this I will create in dead load case and same copy paste in the seismic weight case so that it will be easier. Okay, so here it is a uniform load of kilonewton per meter. So I think it is 9.5. So just say it is in global y direction, so it is minus 9.5. Okay, say add. And another is parapet load, it is minus 3.5, say. Right, so this is for parapet. Okay, so these two loads are not assigned yet, so I need to assign this. So I will go to the view and side view. So for all levels I will assign this 9.5 as a self weight. So select these levels like this, control 1, 2 and 3. Okay, you can check whether all three levels are selected. Yes, all selected. Say go to this, say assign, yes. Okay, loads are assigned. Now go to the top level, select this top level, go to this next load. Now here I just wanted to assign this to the peripheral beam only, right? Not all beams. Okay, so I will just isolate this level first, say new structure, create new. Okay, and then on top of this I will just select this peripheral beam. I just wanted to assign to the peripheral beam only. Okay, this is the parapet because it is a parapet load. Okay, and then go to this, say assign, yes. Okay, now you can display the whole structure with 3D view. Yes, you can check those loads which are assigned to this particular structure are shown in green color. So up iske upar, if you put the cursor, these loads will turn into the green. So these are this load 9.5, these are this load 3.5, and this is this load which is your floor load. Correct? So all loads are assigned now. Okay, fine. So now I want these two loads which is given to a particular member that should reflect into your seismic weight definition. Now I will go into the STAAD editor, which is your last step to understand how to use this STAAD editor thing. So for that you go to utilities. Here there is a command file. Okay, so once you click on this command file, it will ask you to save the model. So okay, save the model, and then this command editor is open. Okay, so now it is open. Okay, here what I want is that you can see here whatever you have defined. Last time I told you you can change this e value here for material definition. So here this you can see this value is 1 2 point something. Let us change it into the actual value of e, which is 5000 root fck, correct? So 5000 root of fck will come out to be 27386. Okay, but it is in kilonewton per meter square, right? So it is 27. I will just change this value 27386 127.88. That is in kilonewton meter square. Poisson ratio you can keep 0.3 for the concrete. So let us say it is 0.3, and density also you can change this to 25 for the concrete. Other things will be same. Okay, FCU value you already changed. Now listen this carefully. Now how to assign this load into the seismic load case. Here you can see whatever the loads you are assigning, load number 1, 2, 3, 4, 5 and 6. There are 6 loads which are already assigned. And in dead load case, where is it? Member load, lower load. Where is the dead load case? Let me check. load. Yes, so this is your dead load check, dead load case. Load number 5 is your dead load, and here you have assigned this floor load, correct? So I will show you this how to copy this into your seismic load definition, right? So here you can see here floor weight is there. Now I will just copy this load, which is your floor load, member load, from dead load case. Remember, don't copy this load case, only load member load, correct? So just copy this particular thing, okay? So just say copy, control C, okay, and then I will just paste this load into your seismic load case, okay? So this is my seismic load floor weight, and here, so just put enter and just say control V. Now this load is copied here in seismic weight. Now here I just wanted to change the direction is not there, so remove this gy from here. Direction I don't want because it is a seismic weight, and then this negative sign, this is first thing. And instead of member load, you just say member weight, okay? So turn load into weight, weight, that's it, okay? That's it, and save this model. So now this load already is generated in seismic load case. Save this model, and then this close this window, okay? Now if any error is there, software will already show you this error in this particular screen. There is no error, so no error is reported up till now. That's it. So this is how this you can create a model in the STAAD.Pro and assign the seismic load to the particular thing. So now we are done with all seismic loads, dead loads, and live load. Now live load again remaining. So let us assign the load into the live load case also, because we have assigned the live load in seismic load definition, but here we are not applied any live load. So let us apply the live load. Just again a simple thing. So live load for the floor from here to here is considered as 2, and roof will consider as 1.5. So two different loads will assign. So say add. So add load atom. It is a floor load. So let's go to the floor load, right? And then here just say pressure equal to 2, range is y, and then you can have range from 0 to, now what is that node number? Okay, so let us check that node number. Geometry, like this is 10.2. okay, so I want 2 kilonewton per meter square from 0 to 10.2. so say 10.2 here, and say add. This is first load. Second, I want from 10.2 to 13.3 intensity equal to 1.5. okay, so this is another level. Just say add. Okay, so let us check whether these loads are properly generated. I think something is wrong here. 10.2 na lete hue, what I will do is just keep 10.5, so that only top level it will generate. Yes, now it is okay, correct? So this is generated at the top level. This is generated for all other levels, correct? So this is your live load. That's it. And now we'll make one combination only. Like that you can create n number of combination. There is no issue. So I will just show you how to create one combination for this. Say add new combination, new. Okay, now we are not creating any load case. We will create a combination here. So let's go to load items, and here load case, here it is a combination, correct? So combination, this is of course a load number 7 is your load combinations. Okay, so I will just create dead load, sorry, 1.5 dead load plus 1.5 live load, just only one combination for your understanding. Okay, so here dead load is added with factor 1.5, live load you have to add with factor 1.5 again, right? And say add. Okay, now here you can see the difference. Here L written, and here you can see it is C written. C means a combination, and all others are load cases. These are primary load cases. This is combination. That's it. So you are done with your modeling with seismic load generation. and the load combination. Now we will go to the pre and post analysis command. We'll understand this and we'll try to run this particular model. Okay. So for that, you need to click on this particular tab, which is analysis and design. Correct? Okay, so analysis and design. So analysis command, just click on the analysis command. Here it will ask you what type of reports to be printed. So I want all, so say all. Okay, so this is analysis command. Before that, we'll go to the pre-analysis command. We'll understand that first. Okay, so pre-analysis command, here you have to define the command. Now here you will get the different option what you want. So what you want is problem statistic, join coordinate, member information. This is all pre-analysis. That means this doesn't require any analysis results to be reported, right? So before analysis only you can have the information, all this information with you. So that is what you call as a pre-analysis. Okay, so pre-analysis is there. So you can select and add one by one atom if you want. I will not add anything in this. So, but there are items like member information, solid information, member properties, material properties, etc. that you can add, correct? And then comes the analysis. So analysis, I will just add all and say add, okay? And then just close this command. You can see here, this is perform analysis print all. Okay, this command is added. Now go to the analysis, post analysis command. What you want after analysis is this. Okay, so once you click on this post analysis, you go to define parameters, and here you will find the different parameters that you want after the analysis. So what I want is I want all these load case to be reported. So select all load cases, and then other properties are also there. So load cases I have selected from here. Support reaction, if you want, you can select. Okay, so say add. So then I will just check on the support reactions also, say add. So these commands are added. You can see here print support reaction, but this command need to be assigned to the structure. So you can select the entire structure and then select to view. Say select to view, assign. Yes, now it is assigned, correct? So analysis thing is done. Now I will just show you some of the properties for this concrete design. Okay, not all, it is not possible, but let us see some of the design parameters also. So for that there are three options here. So just click on the concrete. Okay, now here you can see the by default the code is IS456 because we have already selected configure our model with this particular code. So already this code is there. Now there are three things: select parameters, define parameters, and command. Now how to design this element? That means what you want to design. Either you want to design the beams or columns or all. Okay, that you need to select first. Okay, then the command that you can select from the command menu. Then there are certain parameters like unsupported length, then the reinforcement, whatever reinforcement you are going to use, the characteristic strength of that particular reinforcement, then characteristic strength of shear reinforcement, cover, all these parameters can be defined from here. Okay, so let us go